All right, so this one we'll pick up is 5.2. We're kind of going to zoom through this because I want to get on to some meatier stuff than this. Hey, Matt, morning all. Plenty of room.
Yeah.
All right, yeah, so we'll pick up with, that marker looks fun. It does too. That's what we'll talk about for the next hour here. Will be binomial distribution. So I guess before we begin that, let's put this into context real quick. Lately, the discussions, at least in America, have gotten pretty interesting when it comes to gender. Again, I'm really fascinated by this discussion point because I don't know. I don't know what necessarily to think myself. But when we talk about gender, the old gender construct, social construct, has been that there are two genders. You're either this or you're that, male or female. Now we've gotten to the point where there's, what, 182, 187 genders in the world? Yes?
I thought you were just making up a number this whole time.
No, that's one podcast I heard was 187. So I don't know if that's true or not. I don't know. I haven't verified it yet. But I know there's a lot of genders out there apparently these days. Okay? But if you stop and think about that for a second, we're saying, or that what that construct is saying is there's 187 choices to choose from. Okay? And then when we get into the old, like going into a ballot box, okay, you get a choice. All right? Okay? Is it a yes or no? Think of it like that, a yes or no situation. I go to a ballot box and I vote, and they say, hey, do you agree with this constitutional amendment? A lot of states do that for like referendums, etc. You have a choice. It's either yes or no. Okay, there is no third option. Unlike surveys where they go, do you support the president? Yes, no, not sure. Okay, that would not be binomial. Binomial, again, is just a one or the other. So if you look at it, you have kind of, think of it like this. We have what we're going to call Q, lowercase q, that is going to refer to the probability of success. Okay, whatever that success is. Success in failure. Do you think this is going to explode? Or will this explode? Okay, is explosions good or is it bad? Is it success or failure? Well, if it's a rocket, yeah, that's good. If it's a house, that's not good. Okay? So again, remember, you have to define the words and know what the words are telling you when you set this up. All right? So we have Q, and then we're going to have what we were going to refer to as, right there, sorry. I'm going to come back up here. Oh, I got it backwards. My fault. It's already early this morning. Think of success as P. Kind of backwards. Whew. All right. Where P is your success. Okay. And failure is in terms of Q. All right. Papa and Quebec. So if we go in and we say that, for example, something is going to be successful, again, it'll be in terms yes, P. We also know no is Q. We also said that in every other probability distribution we've talked about, what did we say again the total probability would always be? 1. Yeah. So if the total probability is 1, we know the probability of failure is going to be equal to 1 minus the probability of success. Again, it's binomial. It has to be one or the other. So if the odds of it winning are the odds, so for example, how the Seahawks doing? Kev?
Well, they beat Packers, so they are, I think they're 5-5 now.
Oh, perfect, right down the middle. Okay, so they're 50-50 right now, sorry, yeah, 50-50. Okay, so that logic would be that you only have 100% games, right? So their success would be what we would term it as 0.5. So their no rate or failure rate would be 1 minus 0.5, which would be 0.5. Punt foof.
No coffee.
Oh, yeah, punt. Yeah, that's right, good point. I like the punt. All right. So yeah, if you know you have binomial experiment, then you can calculate binomial probabilities. This is important because binomial probabilities come up often in life. All right. Toss a fair coin 10 times. All right. We're not going to have Nicole do it. She might get injured again. And then find the probability of getting 2 heads. Okay. Question 20 people in class and look for the probability of more than half of them being women. Okay? How dare they assign a binary gender distribution? How dare they?
This is from what?
This is probably written a few months. Probably written a few months ago. You shoot 5 arrows at a target. Find the probability of hitting it 5 times. Okay? You either hit the target or you don't hit the target. Okay? So for example, let's look at just something really basic here. It says deriving probability. Okay? It says, example 521. Suppose that you are given 3 questions. A 3-question multiple choice test. Each question has 4 responses and only 1 is correct. Suppose you want to find the probability that you can just guess at the answers and get 2 questions right. Okay, so it says you have 3 questions. So it'll be 1, 2, and 3. Each question has multiple choice, and it has 4 responses. So we'll say A, B, C, and D for each one. And each one only has 1 correct option. Teachers do this all the time when they make a multiple choice test. I do. When I used to, I would have mine spell out things. To help with the idea that you're going to guess, suppose the test is in Martian. Okay? So it's saying, first up, it says, what is the random variable? Okay? What is the random variable? In this case, what is the variable between all 3 of these problems? In this case, it's going to be the correct answer, meaning what is the variable we're looking for? Okay? Part 2 says, is this a binomial experiment? All right, it says there are 3 questions. Each question is a trial, so there are a fixed number of trials. In this case, n equals 3. Right, we have 3 questions. 3 sample points, okay? Getting the first question right has no effect on the second or third, right? Kind of they're independent questions. Thus, the trials are independent. Number 3, either you get the question right or you get it wrong. So there are only 2 outcomes. Yeah. Question 1, you either choose the right option or it's wrong. Right? There's no third. On a multiple choice test, you don't get partial credit. Okay? That B looks like a D, maybe. Okay. All right? Number 4 says the probability of getting a question right is what? So what is the probability of getting question 1 right? A random guess.
1 out
Yeah,
of 4.
1 in 4. And for number 2 and number 3? Yeah, 1 in 4. So that's why they always say go in and pick C when you do tests. You're going to go in and just, because again, you'll have one shot, unless you know the teacher hates C tests, C answers. But assuming all things are equal, that's what they tell you is pick C and stick to 1 letter. All right? Also, teachers don't pick A and D. They like to pick either B or C if it's a default answer. It sounds really weird, but they don't like to pick the extremes, right? A, B, C, D. A and D are the edges. B and C are in the middle. Just weird. Just think how the human mind thinks. All right? Yeah, so this is a binomial experiment. The big key thing is, in this case, 3 independent samples, but the key is the answers for each variable is either it's right or it's wrong. Okay? So, it says in this case, what is the probability of getting 2 questions right? Okay? So it's built, there it says the solution, it's built the sample space, you know, all 3 are right, 2 are right, wrong, yada, yada, all down to et cetera, right? And it says now once you go in and say, hey, what is the probabilities of getting 2 answers right?
4.
All right. In this case, there was how many total possible responses? 1, 2, 3, 4, 6, 7, 8. Right? 8. It says in this case we can get 2. Oh, it says only 2, right? Yeah, getting 2 questions right. 1, 2, 3. Yep. There you go. Okay. What you did in chapter 4 was just to find 3 divided by 8. However, this would not be right in this case. That is because the probability of getting a question right is different from getting a question wrong. Okay, so what can you do? In this case, look at just the probability of right, wrong for one moment. Okay, again, that means probability of right, wrong is equal to is equal to the probability of right on the first, right on the second, and wrong on the third. Since the trials are independent, then the probability of that specific event happening is equal to the probability on the first times the probability of the second times the probability on the third. Okay, so for that one specific occurrence, and then again, this is what makes binomial different. We said, again, it's going to be 1 out of 4. So it's going to be probability of the first one I got right, ding, is 1 in 4, times the probability of 1 in 4 the second one, and then the probability of the third one of getting it wrong, which is the opposite, 3 over 4. And when we all carry it out, boop, 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 we get the probability. And guess what? That applies to all of them. Because again, it's either right or it's wrong. Right? And then how do you, so then, because we said we had right, wrong, we had right, wrong, right, and then we had right, wrong, wrong, right. So to determine the overall probability, we have to find this probability plus this probability plus this probability. And then we add it up. Right? So then it says, what is the probability of getting 0 right, 1 right, and all 3 right? So what this problem, by the way, is doing is it's setting up the equation to show you where we get probabilities for binomial. Okay? You're going to see this again. By doing binomial probability distributions, we're going to take the probability of success and multiply it pretty much by the probability of wrong. And you're going to get an overall probability. Okay, that's where this is different. Again, one is counter-dependent on the other. The probability of right and versus wrong. Then it says you can now see, you can write the general formula for probabilities for a binomial experiment. Yep, in this case, probability of R right, 1. In this case, if you get 0 right, yep, you're seeing the probability of 0 right to it wrong. And then in this case, probability of 1 right, probability of 2 wrong, 2 right, 1 wrong, etc. So, right there in the box right there, so this is the probability formula, okay? Sorry, the binomial formula for probability of R successes in N trials. All right? So, no!
And is it meaning there with the R, that sample?
Go back to combination.
R is right, never mind.
Yep.
Okay.
So when we did combinations and whatnot, we were talking in terms of
Horrible eraser.
horrible.
Oh,
Ugh. There we go. So yeah, remember with combinations we had N and R, right? So N was,
I thought that was the total, right?
yeah, think of it like that. Yep.
Oh.
N was your total sample, like how many trials, if you will.
Uh-huh.
And then R was how many successes do you have. Okay? So if I look at that equation, it says the probability of X, where R is correct, or the success, is equal to combinations of N and R times the probability of success to the R power. Man, I'm all blind here. There we go. Q to the N minus R power. And again, C we talked about combinations, N factorial over R factorial, etc. All right, so let's explain what this equation is telling us again. All right, so it says combination, we've already talked about, is the number of combinations of N things taking R at a time. All right, so again, we had 12 students. I'm going to pick 4 students. N would be 12, R would be 4. All right, we talked about that. All right, so then that's where combinations come from. So N again is your, like, the sample size. And again, R is what you've picked or successes. Okay, P is the probability of success, right? We talked about right here. The probability of yes, or the probability of success. Q is the probability of failure. Okay, and then we talked about R and N. So if you think about it again, think about it as R and N relate to P and Q. Probability of success, well, we said this is our success number. Probability of failure, which is related to P. If we look up here, this pretty much tells us this is how many students we did not pick. Okay, so let's do an example. All right. Calculating binomial probabilities. When looking at a person's eye color, it turns out that 1% of the world has green eyes. Wow, that's some big trouble in little China right there. Okay. All right. She's Asian and has green eyes. Consider a group of 20 people. Okay. Now I gotta erase the board again. Okay. So it says in the world, green eyes, 1% have green eyes. Okay, so 1% of the world has green eyes. What is the probability people don't have green eyes?
90%.
Very good. Nicole even did a yawning. That's impressive. I'm not going to put no green eyes. I'm going to put not green eyes. Oh my God, they don't have eyes. Okay. So again, P in this case is going to be green eyes. Then Q would be not green eyes. All right, because we said when we began, we said if P is 1%, Q is equal to 1 minus P. In this case, it would be 99%. Right? So in this case, it says, part A, it says state the random variable. Okay? In this case, the random variable is,
1%.
yeah, not the probability, the actual number, but the variable is
Oh,
eyes. Yeah, the eye color. Eye color is the variable. Part 2 explains why it's binomial. In this case, it's binomial because you either have green eyes or you don't have green eyes. Okay, if this was one of those green, red, albino eyes, brown, blue eyes, whatever, that would not be binomial, right? Nicole?
Mm-hmm.
Okay, just checking. You're staring me down. All right. So first, it's telling us, in this case, find the probability, okay, in this case, that, oh, yeah, sorry, let me go back up to the top part. Consider a group of 20 people. There you go. Says you have 20 people to start with. There we go. That's better. Okay. Part C says, find the probability that 0 or none of them have green eyes. Okay? None of them have green eyes. So if we take our equation here, it says, what is the probability that x is equal to 0, where you have a combination, in that case was n factorial, oh, sorry, in this case where r is equal to 0, n is equal to 20. Okay, first part, we'll start with the factorial. Factorial said n factorial, which is 20, over r factorial, okay, times n minus r, oops, which is 20 minus 0. Okay, so that's this C part, times, what is the probability of having green eyes? 0.1. Yep, so that would be 0.1. Oh, sorry.
0.
Hey, good, thank you. There we go. I know what I was
Wake
thinking.
up, wake up.
Oh, God. All right. So the probability right here of having green eyes, 1%. And now it's saying to what power? How many successes do we have? 0. So we put this to the 0 power. Now, if you set P up correctly, Q will be set up correctly. Because remember, they're dependent upon each other. Okay? So, again, if P is 1%, Q is 99%. If R, which is a function of n, is 0, n would be what? 20. Oh, you sound sad, like someone just killed your cat or something. See. Oh, God,
early, man.
What? I get up at 5:30 to go to work every morning. No, hashtag adulting. All right.
I know, I slept in there.
All right, so now we'll go back and do the math. All right, let's look at the combination first. 20 factorial, let's do this. Someone type in 0 factorial on their calculator. Tell me what that number is.
1.
That's right, remember I was foot stomp. Okay, so if this is 1, 20 factorial divided by 20 factorial would be what? 1. So this entire thing goes to 1.
That's a whole lot of work to just 1.
No, it's not. You didn't have to move. You just
No, you didn't, but I mean,
you just go like
it'd be much easier just doing 20
just breathe. 1. Oh, breathing is so tough. Ugh.
Man, sometimes it is.
Nice. And millennials, kids. It's just kids. Simone's son does the same thing probably. Just says it in German. Says it in Swedish. So yeah. Mom, I'm breathing. Okay. All right. So now, who's got their calculator? What is 0.01 to the 0 power?
0.
It can't be 0 because the answer can't be 0 to this.
1.
Yep, that's 1. Remember, anything to the 0 power is 1. And now we're at the last one. 0.99 to the 20 power. Who's got a calculator?
0.879.
Okay, say that again, Nicole.
Oh my god. 0.179. Bleh, bleh. Dyslexic. 0.8179.
There you go.
Jesus.
All right, they rounded it up. And when they get done, they get 0.818. So what the answer is telling me, based off these constraints, it's saying if I have a group of 20 people, what are the odds that no one in that group will have green eyes? 81.8%.
1.8%
Will not have green eyes. Remember, because it was, yep. Okay. Now, the part B says, instead of 0 people having green eyes, all right, we found, again, I can't think of the lady's name in in Big Trouble in Little China. She's that one that has green eyes. Except this case, I want 9. Okay? So it's going to say, what is the probability that of that 20 people, okay, 20 people, 9 of them have green eyes. Okay, so we're going to come in here. Again, first part we set up the factorial, the combination. 20 factorial over r factorial, so that would be 9 factorial, times, let's see, 20 minus 9 is 11 factorial.
Why do you have to multiply that number?
What was that?
Why does it have to be multiplied by p to the r power and q to the n?
Because those are the actual individual probabilities now. You mean this part? You mean the back end stuff?
No, like the first part, why is that part of the equation? Like, wouldn't, in this case, wouldn't it represent 20C9?
Yeah, that's what this is, yes. I'm just setting this up. This is just annotation.
Okay.
Saying what is the probability that you have a success rate of 9 people?
Okay.
So where did you get the 11?
Good point. 11 again is, in this case,
Subtracted.
Oh,
so in this case it's 20 minus 9. Sorry, I was trying to keep it short.
Okay.
Good question. All right, now we go to the next one, the probability of success. Well, we said again, overall probability of green eyes is 1%. In our group, we're looking for 9 people, so it's to the 9th power. The probability of failure would be 0.99. And in this case, it would be to the 11th power. All right, so now we'll go back. Man, where's Tyler at? She's always like,
Oh, she's
math.
at work.
There's too much math. There's not enough math. Hey, there's math now. She should take pictures and send it to her. Say, hey, we're doing math. Look. All right. So take the factorial out. 20, 19, 18, 17, 16, 15, 14, 13, 12, 11. Whew, finally got there. All right, 9 factorial, which is 9. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And this is the 11 down to 1. So this is just the combination portion, what I've got on the board so far. And I apologize for the poor writing. So the numerator becomes 20 all the way down to 1, or I just stopped at 11. Because you know what's coming next. Yep. And then I wrote out 9 to 1, and then I got 11 to 1 here. All right? I'm going to try to squeeze this in. All right, Nicole, what's 0.01 to the 9th power?
That is 1 to times 10 to the negative 18.
Ooh, what was that again? Say that one again. 1 what?
I don't know how to say this. It says 1e negative 18. So wouldn't it be 1 multiplied by 10 to the
Yeah, E means times 10. Okay. And then what is the 0.99 to the 11th power?
It is,
1,
that's 0.895.
0.895.
Yep.
Can I get an amen on that? I just want to verify.
I don't know how to do to the powers unless.
It's
Oh.
a little rooftop.
Yeah, I have that, but it doesn't work, or I just don't know how to use it.
Oh, yeah.
there's
So
the,
if we take 0.99, so 0.99, and then go to,
Wait, why'd you do put one? Oh, for the one,
Yeah.
alright, okay.
the 11, so.
So I thought it was this one, but then I don't know how to do that to the 11.
Okay, you're gonna have white X.
Okay. Okay.
Yep.
Thank you.
Yeah, no
So
worries.
yes, 0.895.
Okay, perfect. All right, so now I'm gonna go back, clean up the combination portion first. 11 through 1 cancels with 11 through 1 at the top. So then we're left with 20 down to 12. Someone want to multiply that out?
I think, I get 6.295, is that the one? I did it already, but I don't
Oh, I'm
remember.
sorry.
Was it 2211753.6? You can do it again.
I mean, I could just do the.
Or just do the combination altogether and tell me what you get. How about that?
Yeah, that is,
20 factorial divided by 9 factorial, and then divided by 1 more time, 11 factorial.
Holy crap.
I just did the 20 and CR9.
Okay, what'd you get?
I got 167,960. That's not right. Did you get that?
You did 20 in CR9?
You can actually run the combination in the graphing calculator. There's software in there that'll tell you how to do it.
Yeah, is it on mine?
No, not on that one.
Again, what was your answer?
It was 167,960.
Okay, that sounds right.
Sure does.
Hold on.
Because remember, I'm looking for an answer that's pretty much 0. That's pretty much it. If we get something that's not this, that tells me that we screwed up somewhere.
I got that answer.
Oh, did you?
Oh, yeah.
Okay. All right, so now then you take this
And you multiply it.
by these two numbers.
Yeah.
And what do you get, Nicole?
I got 1.5 multiplied by 10 to the negative 13th power,
Woo!
which equals 0, basically.
All right. I'll let you guys write that down and I'll explain that real quick.
How does that equal 0, by the way?
That's what I was getting ready to say. Come on, Nicole, without me. All right. Okay, so again, we're gonna hit the I believe button so we can get past the math here. All right. So number times a really small number. So this is 1 times 10 to the negative 18th. That says there's 17 zeros in front of the 1. So for example, 17 zeros after the 1 would be billion. Trillion is 12. Quadrillion,
I guess.
quintillion, sextillion. Sextillion. So dollars. Think of it in terms of dollars. So that would be 1 quintillion dollars. Now, if we do minus 18, that means quintillionth of a cent. You would need 18 million of these, whatever cents these are, to make 1 cent. Yeah, that's a damn small number. So the probability of having 9 people in a group of 20 with green eyes is so damn small. All right, so when you multiply all this out, the answer is 1.5 times 10 to the negative 13. That means there's 13 zeros in front of 0, in front of 1.
So 1.5 times 10 times negative 13?
Yeah. So again, that looks like that's what the probability looks like. To quote Jim Carrey in Dumber and Dumber, it's like you're saying there's a chance, right? He's like, oh, not Mary. Oh, we got. She's like, there's a slight chance of that. Are you saying like 1 in 100, or are you saying, I'm saying 1 in a million? You're saying there's a chance.
So that's how you set up C, correct? You do the 20.
Bay firm.
Okay.
So we don't do it a little different because they use the words at most. So
What do you think the chances are of a guy like you and a girl like me ending up together?
Well, Lloyd, that's difficult to say, and we really don't.
Hit me with it. Just give it to me straight. I came a long way just to see you married. Just least you can do is level with me. What are my chances?
Not good.
All right, so you're telling me there's a chance. All right. All right. So what we'll do here. So 2 things. You can remember set Excel to do all of this for you if you want. Remember, you just have to set up the computer to do the logic. Okay. I don't know if I can't remember if Excel does combinations and permutations, but you might just have to set up the math yourself. It's really not that hard. So for example, the next one I'll look at here says, what is the probability you have at most 2 people? Okay, so again, words have meanings.
It did say 2.
Yeah, so in this case it says at most 2 people. So that means, well, what if I have someone with 1 eye? Is that with 1 eye? Well, 1 person with green eyes. Yeah, that would count. 1, 2, or 0. All right. So on this one, again, because of the wording, they went in and set it up. So they calculated the probability of having 0 eyes, the probability of 0 eyes, 0 green eyes, 1 set of green eyes, and then 2 sets of green eyes. Probability, they added it to the next probability, and they added it to the next probability. So they get the first one, so then they know the overall probability in this case, 0 to 2 would be 0.9999.
Oh, so you have to do each individual one, then add it up at the end.
Correct.
Okay.
So again, we're doing that again because it's asking, what is the probability at most there are 2 people? Okay, or it'll say, what is the probability of having 4, up to 4,
Well,
right? So in that case, yeah, you'd be adding 0, 1, 2, 3, 4. Okay? That's what it's talking about right here. At least 4 means 4 or more. Okay? Find the probability of x being greater than or equal to 4. Which in this case, we already found the probability of having 9 is pretty much 0.
Still a chance.
There's still a chance. All right? Exactly. All right? Do you guys want me to run through this part F, how they did this? But it's pretty much the same one, just each individual one. You just have to keep track of the probabilities themselves.
I'm interested in H.
Oh, okay. Yeah, let's go on H. That's a good one. In Europe, 4 people out of 20 have green eyes. Is that unusual? Okay, so don't read what's on the board yet.
No solution.
Okay, don't read what's on the board yet. Let's talk about that for a second. Is that unusual?
Yeah. In the world?
What was the entering argument?
In the room.
What did it say?
4 people out of 20 have green eyes. Is this unusual? Is that what?
When looking at person's eye color, it turns out that 1% of the world has green eyes. That was the entering
Oh,
argument.
that.
So it's,
Not be unusual for Europe, but maybe that's where the 1% is that
Yeah.
the majority of the 99% of that 1% live in Europe.
Yeah.
okay.
Might not be unusual.
Kim Cattrall. By the way, this is a John Carpenter movie. You didn't know? John Carpenter's the one who did like Nightmare on Elm Street, Escape from LA, Escape from New York. And this is Kim Cattrall before her,
Big Sex and the City.
yeah, slutty phase on So the movie is, he needs to sacrifice women with green eyes so that he can be young again.
2 girls with green eyes? All these years.
You bastards, unchain me. You're not gonna get away with this.
Okay, so that's not the clip I was thinking of. Oh, here you go. Yeah. She's Asian and has green eyes. That's what. Yeah. You know what Jack Burton says in a time like this. That's probably one of the best quotes in the movie. I gotta play that. Sorry.
I had never
When some wild-eyed 8-foot-tall maniac grabs your neck, taps the back of your favorite head up against a barroom wall, and he looks you cryptic in
Let's
the
see
eye
which
and
one.
says,
The one I'm thinking of.
"Dude."
It's got to be the number one. Yep, there it is.
You remember what old
So,
hot in here, is it just me?
Kurt Russell.
Yeah.
You know what old Jack Burton always says at a time like this?
Who?
Jack Burton, me.
I love that quote. He just gets done making out with Kim Cattrall. He's got this lipstick on. He's supposed to be this badass. The whole movie, he pretends to be this badass. And like, there's a fight scene. He like shoots the gun. And like, concrete hits him in the head, and he passes out. Okay, so where was I going with this? So let's go back to Green Eyes. Why that movie made a big deal of the character, the Asian woman with green eyes. All right, is green eyes a recessive or dominant trait? Yeah, it's a recessive trait. I've really been thinking a lot lately about recessive traits because I don't think recessive traits are as recessive as they tell us. Meaning, as in we get it in our mind it's recessive, right? But then, if you guys know the story of like the first English colony in the New World, Roanoke on the Greater Outbanks, and they all disappeared. And then a few years later, they found Indians with green eyes, and they're like, "Oh God, what happened here?" Right? But green is recessive, right? I'm trying to
But
rethink
that doesn't
this.
mean it's not dominant.
Correct.
It just means there's less,
I tell you what,
Isn't
my
that what it
wife,
is?
she's overtook my son. He looks nothing like me.
Kev, there's probably
I have blue
more
eyes.
to that logic.
He looks-
Kevin, you probably should reword what you said.
It was true, my friend.
I know what you're saying. Yeah, my son doesn't look like that.
Because he's got, my wife has like curly, well, she had curly hair. He's got curly hair, thick hair, brown eyes, darker skin than me, obviously, and nothing like me.
Same thing with my sister, she has red hair, but doesn't have turns out brown.
I'm pretty sure I was there.
Yeah, that's what I was gonna say. You should probably reword that, Kev. That didn't come out right. Like,
I mean, yeah, her Latino
Yeah.
genes just took over
Oh,
and
yeah.
kicked everything about the Scandinavian look out.
Yeah. I have a friend who's Mexican, green eyes.
yeah.
It's crazy.
Wow, that's
And so it's oh,
Doesn't it take like both parents have to have the recessive
yeah.
trait for it to appear?
Yep. And I think one of the fallacies that
So you have
when they teach us biology, I think it's, I don't want to say it's the appropriate terminology, but when we say dominant recessive, we tend to think dominant will always win.
yeah.
So then, in our minds, we tend to think this, like, you're right, this, well, blonde hair, red hair, whatever it is, the recessive is always going to die out. That's not true. And I don't know, it's just, I've been rethinking a lot about that.
So,
But, oh, I'm sorry, go
I
ahead.
was just gonna give a story. When I was in high school taking anatomy and physiology, where it was,
Yep.
when we learned the stuff. And I have a lot of recessive traits in me, and I thought that meant, and seriously, at the time I asked my teacher, does this mean I was like super close to being like deformed or something? Cause it comes across
Yes,
that way. It makes
it
you
does.
feel like there's something wrong with you.
Correct. And then, so when we use dominant recessive, your mind inherently goes to the, well, black hair is dominant, it's gonna win every
Yeah,
time.
and
And
that must be good.
Correct, or whatever it is, whatever that is. And so you sit back and, yeah, so last year I've been thinking about that term, dominant recessive, a lot, and I don't like that, how, because it automatically puts connotations in your mind of what it means. Words have meanings, right? What we say. All right, so if you put it in that context first, right? So let's look at the world. It says first, Europe, in Europe, all right? What's the population of Europe?
Europe is usually against in Europe. Europe is made up of so many different countries. If you take Romania, for example, Bulgaria, people are typically on average very dark hair, olive skin, and very
Greeks.
southern Greeks.
Yeah.
And if you go up to Ireland, and it's much different. So Europe as one term is just too much to put in one
Yes.
thing.
And we almost have the same thing in the U.S. as well. The U.S., even if you said North America, because then you got like Canada, where there's like the Eastern, with all French, you get those French features still in people, where it's like, oh, okay. North Dakota, Minnesota, you get all the Scandinavians, the Germans in the Midwest, Hispanics out west, yeah. Hawaii, you include Hawaii in North, no, not specific, but Alaska, Inuit tribes, Indian tribes, etc. That's a good point. See, there you go. Already analyzing it from that standpoint. But if we look at Europe, generally speaking, there's about, what, 360 million? 370, I think?
It says 742.
742 million?
That's what I Googled.
Shit. Okay, that's more than I thought it was. Okay. I wonder what they think is I wonder if that includes all of Russia. Includes all of Russia, or they stop at 0 mile?
What do they say?
But let's assume for a second it's 700 million.
Mhm.
All right, 700 million. Okay, what's the world population?
Oh, maybe close to 8 million.
It should be 7. Some a little over 7. So let's look at it mathematically real quick.
10%.
What was that?
Oh,
10%
it's
European.
7.5 billion.
Yeah. So if it's about 750 million over 7.5 billion, yeah, it's roughly, as Simone said, roughly about 10% of the world population. Okay. China alone has 1.5 billion people.
1.33.
133? Okay. China has said single-handedly if they want to beat the U.S., they'll just drop their people in America. And then, but what they don't understand is don't invade Texas. Don't invade Texas.
Unless it's Texas.
Whew. By the way, the Soviets, if you don't know that, in the old Cold War days, their attack plans on America did specifically say that, to expect high, quote, what was it, high insurgency casualties if invading Texas. So if we look at it like that, 10%. Now, if it says Europe has, of that 750 million, there's 4%. All right, and they said the overall world was 0.1, or sorry, 1%. Is that unusual? How common, as Matt said, I have a friend who's Mexican who has green eyes.
It's crazy.
Yeah, it's not very common. It's really not very common outside where the recessive trait is dominant. All right, green eyes would be more common, meaning that it would, in this case, be, I won't say more dominant, but it would be more frequent, right? Yeah.
Well then, okay, so you would say, so brown eyes obviously in the
Yeah.
Hispanic,
Dominant.
not culture, but like,
Yeah.
the Hispanics is very dominant. What would it be, like, how is that for skin tone? Because until I moved to America, I had never seen a black person in my life.
Really?
Yes.
Not at school?
No, not
Because remember, she's in Bolivia. She's in Bolivia.
So like, really the only black people are in the jungle? Sounds really bad, but does that?
Be the same
On
thing.
TV?
No.
Man.
I was in, my grandma brought some Jamaican friends over and her friend had grandkids and I wouldn't shake their hand because I thought they were dirty. I was, okay, but keep in mind I was like 4 at the time.
Yeah.
But still.
Understandable.
You did know.
So does that like happen with skin tone too?
Yeah, that would be the same thing. What is, or kind of, because again, the average of the more dominant or common would be the proper word in this case, would be more of a darker tone. So like, there's a show I used to watch on Comedy Central called Thrown Together, and they said, oh, we got the best, no, it was on Archer, where Pam says that she's like, oh, Lana and the gay guy say they want to have a baby or something like that. She's like, and Pam says, oh, it's going to be the best dancer ever. Like, and she said, quote, the mochaccino one's the cutest, unquote. Which is interesting because that's what people are arguing, that's what's going to happen with humanity as it evolves. I don't know if that's true or not because I've seen a lot of things already that don't necessarily point to that. Because again, there's variability in the data. But if we look at, that would be the exact same thing, Nicole. If we look at the world for a second, okay, so if you look at, here's Europe. I actually had a cool map drawn. When did I draw that? Was that last night or was that before?
Thursday.
Okay, so if we got the map, Australia, there's India right there. Remember, the world's population is right here, most of it. India and China alone have, what, 30% of the world's population? The last time I checked, there's no green eyes in India.
Despite the one child policy in
Which they're getting rid of. You don't know.
Yeah.
What's that?
China's getting rid of the one kid policy.
really?
I
Oh,
thought
yeah.
they already did.
I think they have
Oh, they're
actually.
gonna balloon up even more.
China is becoming extremely aggressive. If you do not know, I highly, highly recommend you do some homework on China. To include their Black Mirror policy they have a social media thing now, pretty much, where they're controlling the population, meaning they're announcing it on the overhead, saying if you do not be a good person in population, we will dock you points. And they have a point system, so if Nicole spits in the streets, is rude, or preaches against the country or against the state, you get points knocked against you. And those points, now you can't go get a lease or rent an apartment.
So 2 demerits and you're putting time out?
Yep. So that Black Mirror episode is so true. If you have not heard, Venezuela has now asked China to help them out to develop their own. If you guys also don't know, if you don't know, Google, hey, you're gonna hear this. Google has been working with China for the last year and a half to, quote, develop China's own internet, unquote. They want to develop a search engine that can only be used in China.
Which is bullshit.
And again, who's funding it?
China.
Nope, sorry, who's doing the work? Google.
Which a lot of the employees were pissed about.
Correct. Which, remember, there's a lot of people nowadays who complain about corporations because they get all their money, they start from, then they go, we have no loyalties.
Yeah, it's messed up.
Especially the American ones. They have no loyalties. But then at the end of that's why, I like German companies. At least at the end of the day, they go, we're Deutsch, get out of our way. We'll screw our cars up as much as we want, get out of our way.
Isn't Australia kind of like that too?
So if you guys don't know about it, so put that into context. If majority of your world, or a big group of your world, has 0%, right? That means off the block, as like kind of a weighted average, you've already got 0 so much up to 30%. So think about pie piece. If this much is your pie is 0%, okay, that's billion, whatever, and Europe right here is 4%, it's going to play with that number a little bit. Now if we add in North America, the other continents, etc., I would argue that that's not abnormal for the context of Europe. Meaning in the world, for the world average, yeah. But when you put it into a larger context, yeah, it's normal. Because remember, that overall average has highs and lows itself. That's an average number. It's like we talked about with average. Average is the middle point of the extremes, all the points. Okay? How about we do one more? What time is it?
It's 10.
Let's go get something to drink real quick. How's that sound? We come back.
Thank God. Biscuits.
What was that?
I was thinking about biscuits.
We come back, we'll do example 5.2 down here, where it says calculating, it'll be autism. By the way, there was a story that came out yesterday, I don't know if they saw this, they gave antidepressants to monkeys, I'll see if I can find it, and they noticed rates of autism in monkeys.
Whoa.
Again, statistics and studies don't say this causes this, but we see a trend.
Oh, jeez. Yeah.
Is it passed on to their children?
Don't know. Good question. Good question.
You said we're gonna do
Oh, what study would look like.
2-4. Yeah. If you guys, let's go. If you guys want to take a quick break, go get some coffee, or anyone want anything from the bakery, or and then we'll come back and we'll pump this out. And
Travis, what time are we gonna stay till?
yeah, we'll see.
Okay. Just wondering.
Yeah. Like I said, I'm recording it all, so that's why I'm like, oh God, Nicole, stop talking.